Greetings to all. The session is regarding the intermediate chemistry. We'll be fetching for your international entrance and competitive exams as well. India is conducting twice a year JEE Advanced, JEE Mains examination for the better score, and that will give the way to get the admission into IIT and NIT examination, NIT stream, that is a technical domain engineering, and NEET exam will be conducted all across India. That is for medical entrance examination. Medicine students will get the admission over there. And Telangana, Andhra Pradesh government are conducting MCET examination for get the admission into BTech stream. That is the technical domain again. In addition, if you are aspiring any government organized examinations, there will be the compulsory paper called General Studies. In that, general science content will be there. The session what we are discussing is very much fetching towards that kind of preparation. Let's enter into our today's session. Here is the question related with the IUPAC nomenclature. IUPAC stands for International Union for Pure and Applied Chemistry, where the complex is provided here. A cobalt complex accompanied by chloro, nitro, amino, and this is the kind of complex which accompanied by the positive charge. The topic is related with ambidentate ligand. Ambidentate stands for if any ligand, like ligand is nothing but any kind of the species which having natural tendency to release at least one lone pair of electrons is called a ligand. And ambidentate ligand is nothing but within the ligand more than one kind of atom having natural tendency to release the electron pair. If you go for nitro or nitrito, so both are looking same, but there is a simple stratification among the release of electrons. How can we see? NO2 is called nitro. ONO is called a nitrito, right? What difference you can notice? The difference is regarding electron releasing tendency. In nitro, nitrogen is responsible to release the electron pair. In case of nitrito, ONO can be taken into the consideration. Oxygen is able to give the electrons. So within the NO2 only, two species having natural tendency to release the electron pair, that is said to be ambidentate ligand. Okay, so this is the simplest example regarding ambidentate ligand. NO2 having nitrogen and oxygen, both the atoms having tendency to release the electron pair. Hence, nitro, nitrito, which is the ambidentate ligand. So that if this is the case, how can we identify which atom is giving electrons and how can we pronounce in the IUPAC nomenclature? That is the topic we are discussing in the question number 1. And this is the coordination complex called tetramine, chloro, nitrito, and cobalt 3, right? So tetramine stands for how many amino are there? In order to assign the nomenclature for the coordination complexes, we have to follow alphabetical order. Alphabetical order, amino A comes first, right? So that let me pronounce tetramine first. Okay. After mentioning tetramino, here another ligand called chloro C. C will come next time, so that tetramino followed by chloro will be mentioned, and a nitrito can be taken. This nitrito, if nitrito is mentioned, later you have to give N. N stands for, in this NO2, nitrogen responsible to release the electron pair. That's why N mentioned. If nitrito O mentioned, that is called what? Oxygen is releasing electrons. So that here, tetramino, chloro, nitrito, N, cobalt 3. Why it is mentioned 3? Because here chloro is there, NO2 is also there, and one positive charge is there. The entire charge now counterbalanced with the +3 charge on the central metal, so that oxidation state of the cobalt metal is said to be +3 around the central metal. So this is the way tetramino, chloro, nitrito N, cobalt 3 cation is the name of this. Being it is a cation, you have to go for the cation. Name will be assigned. This is the way IUPAC nomenclature will be assigned in accordance with the alphabetical order, followed by the charge distribution, and ambidentate ligand if present, what atom donating that element symbol to be mentioned. N stands for nitrogen releasing electrons. In case of ambidentate ligand, this is the way you have to give. N stands for nitrito, nitrogen is releasing electrons. If oxygen, if the case ONO is taken, we have to mention O. like this, but here N mentioned for nitrogen as the electron releasing one, right? So if oxygen is releasing, the entire name will be represented as tetraamino chloronitrate O cobalt 3 cation, right? So this is the question related with the coordination complex in accordance with the IUPAC nomenclature. Specifically, ambidentate ligand is how can we designate ambidentate ligand in the coordination complexes, right? So question number one, the correct answer for this will be tetramino chloro nitrito N cobalt 3 cation. This is the way we can pronounce. Move on to question number two. Question number two collected from Cambridge Assessment International Education. And here is again the continuation for the earlier session where malic acid was taken into the consideration. And this malic acid is a dicarboxylic acid with the hydroxyl functional group in between and subjected to heating process. Whenever malic acid is heated, it participated in a dehydration process. OH minus, H plus got removed so that carbon-carbon double bond is located in between the two carbon atoms. Carbon-carbon double bond is generated. Here the question is, explain why the compound S is described as unsaturated. How can we say this compound, whatever generated after heating, dehydrated product, this is said to be a dehydrated because we removed the water from malic acid by heating process, so that this dehydrated product is designated as unsaturated. What reason for that? In order to explain, first of all, we have to know what is meant by unsaturation. Any compound is accompanied by the pi bonds in addition to sigma bonds is called unsaturated. Pi bond is formed by lateral overlapping of the orbitals, unhybridized orbitals, and that will gives rise to the either double bond or triple bond. Right here, you can notice benzene is having double bonds in this. That all benzene double bonds are in conjugation, and here another double bond is there, which is outside the ring. Exocyclic double bond is also there. All these are said to be unsaturated compound, unsaturated double bonds only. If you go for the acetylene, acetylene is accompanied by the triple bond. It is also the part of unsaturated compound. Any compound which is having pi bonds in addition to sigma bond is called unsaturated. Malic acid is said to be unsaturated due to the presence of double bond among the carbon-carbon, and here double bond among the carbon oxygen, double bond among the carbon oxygen. This is the way unsaturation is represented on a malic acid after the dehydration. So for question number two, the correct answer is due to the existence of double bonds among the carbon-carbon, carbon oxygen as well. The dehydrated malonic acid is said to be an unsaturated compound. This is the way you can answer. And all the double bonds are highlighted with the boxes like this, right? And move on to question number three. Question number three is given from JEE Advanced 2017 question paper. Paper one question it will be. An ideal gas expanded from P1 V1 T1 to P2 V2 T2 under the different conditions. Initial pressure, volume, temperature are mentioned with P1, V1 and T1, and final pressure, volume and temperature are designated as P2, V2 and T2 under different conditions. The correct statements among the following are. So what are the correct we have to identify? A is correct, C is also correct. Let's see how can we explain. The work done on the gas is maximum when it is compressed irreversibly. Irreversibly means only one direction it possesses, that is called irreversible. Reversible means forward, backward, both are possible. Work done on the gas is maximum. Irreversible change you are doing, and work done on the gas. So the gas taken on that, you are applying the work. When it is compressed, you are applying the pressure. Compression means applying the pressure externally. And P2, V2 to P1, V1 against a constant pressure P1. Okay, so that work done will be maximum. Being it is irreversible, all the gases whatever present got compressed in the maximum extent, so that work done will remain to maximum. That is the correct answer only. Because being it is irreversible process, always it used to convert a reactant into product. P1 is turning into a P2 value, and whenever you are going to apply the pressure externally, whatever work you are doing will become larger in the content. If the expansion is carried out freely, it is simultaneously both isothermal as well as adiabatic. Okay, expansion is carried out freely. Expansion means what? You're removing the pressure, so that what happens, all the compact molecules got separated with the maximum distances, which is called expansion. Simultaneously, isothermal as well as adiabatic. Isothermal denotes what? Where the temperature remains constant. Adiabatic, neither matter nor energy get transformed from the matter to system and system to matter. There is no exchange of matter, there is no exchange of energy. If that is the condition, that is called adiabatic. Adiabatic, where energy transfer is not possible and matter transfer is also not possible, right? So if the expansion is carried out freely, the question is incomplete, to be completed, to be expanded more. The work done by the gas is less when it is expanded reversibly from V1 to V2. Work done by the gas less when it expanded reversibly from V1 to V2. So what we are doing, we are expanding the gas reversibly, means there is a conversion by in the both directions, conversion is possible, hence we can say reversibility. Under adiabatic conditions, adiabatic condition denotes what? Neither matter nor energy can be transformed between the system and surroundings, as compared to the expansion reversibly from V1 to V2 isothermal conditions. Adiabatic process is giving the less amount of work done in comparison to the isothermal constant temperature, right? So this is the correct explanation what they are saying. In the adiabatic process, this work done will be larger reversibly, but isothermal process work done will be lesser in the extent. The change in the internal energy of the gas is zero. If it is expanded reversibly from T1 to T2, positive. If it is expanded reversibly under adiabatic process, T1 is not is equal to T2. So here T1 to T2 is the isothermal process, right? T1 to T2 is said to be isothermal process, and positive if it is expanded reversibly under adiabatic process. Positive is wrong. In both the cases, it will be zero only. That's why it is not the correct answer. We will get the extensive explanation for this question by taking into the solution part. Ideal gas is compressed irreversibly. P2, V2 is converted into P1, V1. Again is the constant pressure. That is taken as the P1. Then work done will on the gas will be maximum. So being it is a reversible process, whenever you are applying the pressure irreversibly, that will gives rise to the maximum extent of work. Both isothermal adiabatic free expansion, work done will be zero. Work done will become zero due to the absence of external pressure. In the isothermal process means constant temperature, adiabatic process. In both the cases, whatever work done by the system and surroundings will become zero because external pressure is not applied. When pressure is not applied, work done will become zero. Adiabatic conditions, work done is lesser than isothermal conditions. Adiabatic conditions always, what extent work is done is lesser in comparison to the isothermal process. Here, if you observe in this, pressure is taken on the y coordinate, volume is taken on the x coordinate. Okay, so this is the case. Work done adiabatic and work done isothermal, both are mentioned over there. And what it is explaining here, if you observe clearly, if the volume is becoming V1 to V2, that is AB curve and AC curve, both are mentioned over there. So volume changing from V1 to V2, right? Whenever volume changing from V1 to V2, reversible isothermal, AB curve represents reversible. Reversible means forward, backward, both are possible. Isothermal being it is the constant temperature. And AC curve represents what? AC curve represents adiabatic process, right? So AC is the adiabatic process. It is at the curvature at lowered the magnitude in comparison to the isothermal. This is the of higher magnitude, so that adiabatic is having lesser value in comparison to the isothermal process. By this graph itself, we can notice this is the magnitude related with adiabatic process, always less in comparison to isothermal. From the graph itself, you can clearly depict that, right? Move on to next. Irreversible process, both the conditions internal energy change will become zero. Internal energy will not be varied, either it may be adiabatic or isothermal process, but they are saying in one condition it will be zero, in one condition it will be positive. This may not be possible and clearly mentioned with the graphical representation. Pressure, normal pressure is changing from P1 to P2 and V1 to V2. Irreversible process, this will be the slope you can notice. In both the cases, internal energy will not be varied. Internal energy remains a constant. D is correct, not the correct explanation. A is correct and C is correct. For question number 3, option A is correct and option C is correct. Move on to question number 4. Question number 4 is again collected from JEE Advanced Question Paper. The color of X2 molecule of group 17 element changes gradually from yellow to violet down the group. Topmost elements are yellow in color, and as we descending down the group, that color will be intensified and slowly transforming into the violet color. Everybody aware, iodine granules are violet in color, and topmost gaseous component fluorine is a pale yellow, and chlorine is the yellow color liquid itself. Bromine, move on to brown color liquid it will be. Iodine is the violet color granules, you can notice. So that yellow is transforming into a violet color in the group 17. Group 17 belongs to what? Halogen family, and it is the part of P block elements. X2 denotes what? Halogen molecule. That might be fluorine, chlorine, bromine, iodine. And this is due to there is a kind of fact they provided. In order to support this fact, what is the justifiable answer? So the answer can be mentioned in all 4 options. We have to notice which are correct regarding this. Physical state of X2 at room temperature changes from gas to solid down the group. Obviously fluorine is the gas, chlorine is also the gas, liquefiable gas we can say. Bromine is the liquid at room temperature, but iodine is the solid. Slowly, gaseous component, liquid component, and we turned into a solid from top to bottom in the group. But by this, we can't explain why the yellow to violet color transformation is possible with this. This is the correct fact only, correct explanation only, but not supporting whatever they are saying. Why color change noticed top to bottom, that is not explained with this physical state. Fine. Decrease in the ionization enthalpy down the group. Whenever you consider ionization enthalpy, what is the definition for that one? Amount of energy required in order to remove the electron from the 1 mole of the gaseous atom is said to be a ionization enthalpy. Right? Ionization enthalpy is nothing but energy required to pull the electron. To remove the electron, how extent of energy we have to expend. So that when we are descending from the top to bottom, gradually ionization enthalpy values got decreased. That is also correct, but it will not give the right glance about the yellow to violet color change in the group. Decrease in the pi star to sigma star gap down the group. This is the correct one. Pi star orbital to sigma star orbital, both are at the top level. So as we are moving down the group, what happens? Pi star, sigma star are in the close vicinity. The distance got decreased. Whenever distance decreases, electrons are easily excited. So that whatever excitement of electrons are there, that gives rise to the intensified color. So that color is intensified yellow to violet. This is a correct explanation we can say. Electron excitement becomes easy because of the smaller distance between them. And decrease in HOMO to LUMO gap down the group. So what they are saying in the C, that is also similar to this HOMO to LUMO. HOMO stands for highest occupied molecular orbital, LUMO for lowest unoccupied molecular orbital. Pi star to sigma star is nothing but HOMO to LUMO only, right? So electrons whichever present is called in the last one is called HOMO. Whichever electrons from where electron distribution is not there, that is called a LUMO, right? So where electron contribution, electron occupation got stopped is called HOMO. Where electron occupation got not there and it is vacant, from that orbital we have to consider as a LUMO. So that both are same only, C and D are same only. So that C is correct, T is also correct. Let's see how can we explain. The physical state of halogen changes from gas to solid. Fluorine is the gas, chlorine is the gas, bromine is the brown color liquid, but iodine is the granular solid, violet granular solid, so that it is correct only. But it doesn't show the effect on color of that gases. Ionization enthalpy gradually decreases down the group. This is a periodic property we can notice, and there is no relation with the color property of the substances. Pi antibonding orbital, sigma antibonding orbital gap decreases in the valency shell as we are descending down the group, which is highly responsible for the excitement of the electrons. Transfer of the electron becomes very convenient, so that colored property got intensified, right? So this is the way we can notice, and HOMO LUMO also remains same. Occupying electrons are present in the HOMO. This is pi star 2px orbital and pi star 2py orbitals. Here two electrons you can notice, so that it is the last level where electrons are present, which is said to be highest occupied molecular orbital. And LUMO is sigma star 2pz0. Sigma star means what? Antibonding sigma orbital. In this you can notice zero electrons, no electrons are there, no, so that we can say lowest unoccupied molecular. Unoccupied means no electrons, molecular orbital. So HOMO is pi star, LUMO is sigma star. Whatever they are saying in the gap is less, same will be noticed in HOMO to LUMO configuration. So that bond distance is less in between HOMO and LUMO. That's the reason why electrons traveling easily. Color of the halogens also intensified because of this flexible motion, right? So this is the way we can answer question number 4. C and D are the correct answers. Move on to question number 5. Question number 5 collected from IMSET examination 2023, and it is the part of what we can say physical chemistry part of polymer molecules, right? So there is a certain extent of physical chemistry context will be there in the polymers. We can calculate the molecular weight. Molecular weight of polymer calculation is very complicated because of larger in the size. The polymers generated in the huge quantity, we can't go for the calculation with the normal method. There are 4 different methods are assigned for molecular weight calculation. Among number average, weight average are the most commonly observed molecular weight calculation for the polymers, right? So here is the question related with the molecular weight calculation for the polymer. A polymer sample contains 25 molecules with the molar mass 20,000 and 25 molecules with the molar mass 40,000, right? So 25 molecules 20,000 molar mass, 25 molecules 40,000 molar mass will be there. The number average molar mass to be calculated, and it is calculated as 30,000. How can we get 30,000 as the number average molecular weight? We will go for the calculation. Let's see how can we calculate. Number average molecular weight is designated as Mn bar. This bar represents what? Repetition of units will be there, no? In order to mention in the simple formula, Mn bar will be there. Mn bar is equal to sigma. Sigma means what? Summation. It is the part of summation. Whatever the lengthy chain you can notice, all can be taken as the addition, summation, right? So sigma represent that summation. Sigma Ni. Ni means what? How many number of that kind of polymer molecules we have. And M bar denotes what is the molecular weight of them. Molecular weight, number of polymer molecules into molecular weight of them by sigma Ni. Sigma means what? Summation Ni. How many entire polymeric molecules we have? This is only number, but not molecular weight, only number to be taken into the consideration. Mn bar is equal to sigma Ni, Mn bar by sigma Ni. Sigma Ni. Okay. So here we have to go for summation, right? Ni means what? Number of polymers they mentioned with 25 molecules and 25 molecules, right? So that here 25 molecules, these 25 molecules, what is the molecular weight for them? 25 molecules are corresponding 20,000, molecular weight of the 20,000. So Ni into M we have to go for, so that number is 25 into a molecular weight is 20,000, and the second polymer is having 25 molecules, 40,000. So that let me add 25 into 40,000, and denominator term what we have to take, sigma Ni. Sigma Ni means the number of total number of polymeric molecules. First polymer of 25, second polymer of 25. 25 by 25 plus 25, 50. 25 into 20,000, 5 lakhs. 25 into 40,000, 10 lakhs. They got summed up, summation of 5 lakh plus 10 lakhs by 50. If you go for this calculation, 30,000 is the overall molecular weight of the given polymer. That is given in the option number 1. For question number 5, option number 1 is the correct answer. Move on to question number 6. Among the following sulfur containing amino acids are. Everybody aware about amino acids? Amino acids are the starting monomers in order to synthesize the most proficient biomolecules called proteins. Proteins are very essential component for healthy living organisms, which are the growth factors. There are 21 amino acids are present in the entire series, and which can be combined in such a way protein synthesis is carried, which are linked by the peptide linkages. The question is, sulfur containing amino acids to be depicted. There are 4 options are provided: lysine, cysteine, proline, and methionine. Among these many, B and D are the correct answers. Cysteine and methionine are the part of what? Sulfur containing. Thio here, within this option you can find the clue. Thio always designated for the sulfur only, so that here you can find out one of the option. D containing options are only one. Thio containing options are only one, so that in this way also, in the logical manner also, you can answer this question without knowing exact structures of these many monomers. Only by knowing thio means sulfur, that way also you can conclude the answer. So B and D are the correct answer. Let's see the individual. Lysine. Lysine is the longest chain with the carboxylic acid. CHNH2 will be there, and here you can notice 1, 2, 3, 4. 4 CH2 units are there, and again on the terminal center you can notice the NH2. 2 NH2 are present, hence lysine is the example for basic amino acid. So because one carboxylic acid cancelled with one NH2, and the leftover will be NH2. NH2 accompanied with the negative, basic character, basic nature. So that lysine is the best example for basic amino acid. If you go for cysteine, cysteine is having carboxylic acid on one terminal, and here alpha position NH2 is there, and one CH2 is having SH. SH is called thiol. Thiol is the functional group additionally present in the cysteine, so that it is the sulfur containing amino acid. And move on to proline. Proline is the one and only one secondary amine in the entire amino acid series. All the amino acids are having primary amines. Here NH2 will be there, but here NH is there in the ring system, and that is accompanied by the 5-membered ring. We can say pyrrolidine, and accompanied with the carboxylic acid like this. This is the way proline can be mentioned. And this is a better catalyst in the organic research and synthesis. And another that's we mentioned methio. Thio means what? Sulfur. So that it is the part of sulfur containing amino acid. Here carboxylic acid, here NH2 is there. CH2 is accompanied with SCH3. This is called thioether. If you find oxygen over here, what you can say, ROR is called ether, no? In a similar manner, if oxygen replaced with sulfur, that is said to be a thioether. Methionine is said to be a thioether. Cysteine is called a thiol. Thiol means if you have OH here, that is called alcohol, right? In the same way, if SH is there, that is called thiol. In this manner, Among all, cysteine is having SH, and methionine is also having sulfur as a ether linkage, thioether linkage. This is the way you can answer the question. B and D are the correct answers for this. For question number 6, option number 3 is the correct answer. By this, we entirely completed the session where we gone through the different segments of the chemistry and different dimensions got covered over there, different perspectives got clearly explained. The concept is purely examination oriented and knowledge imbibing destination point, which gone with the IUPAC nomenclature and a problem solving analogy is mentioned over chemical kinetics, colligative properties, reaction mechanism, and biomolecules, organic section, entire dimensions, polymer chemistry, entire dimensions which are present in the chemistry field. Being chemistry is a multidisciplinary, it is connecting with the various branches, all got covered, gives rise to the increase in the interest regarding the preparation towards chemistry. Hence, I'm sincerely requesting to like the channel, comment about your experience regarding the entire video, and there is a question regarding the session in this amino acid. Can you mention the examples for acid amino acid? Now we gone with the lysine is the best example for basic amino acid. If you know any examples regarding acidic amino acid, you can comment over here and share with the aspirants who are serious about the examinations, either entrance or competitive exams as well. You can definitely share with them so that it will be helpful, and subscribe in order to receive more updates in the near future, so that we are going to cover most of the content related with this intermediate, so you can definitely crack whatever you're aspiring for. And thank you very much for your serious preparation and sincere observation. Thank you one and all.